Now let's solve some examples. Example number 1 is a car accelerates uniformly from rest. This is the initial speed of the car. So what you have to do is you just list down the given quantities. What are the given quantities? So the car was initial at rest, initial speed 0, to a speed of, this is initial speed, this is a final speed. So it is accelerating from rest to a speed of 6.6 meter per second in, this is time, this is t, in 6.5 seconds. So we want to find the distance the car travels during this time. We want to find s. We want to find s. So what is required is we are asked to find the value of acceleration, distance. We want to find s, question mark. So what is the total distance traveled by this car during this time? So let's see now, these are our given quantities. So which formula do we have to use? Now let's choose the formula that helps us to find the distance traveled by this car. So shall I use distance equal to average speed times time? So we have, let's list down the formulas for distance. The formulas are, the formula are s is ut plus 1 over 2 at squared. In this case, to find distance traveled, I have to know a first. We have to see, in this case, we have to know the value of a. So it will be two-step process. First, we have to find a using the formula a, which is given by final velocity minus initial velocity divided by time. Using this formula, I have to find a first and substitute it in this equation so that I can find s. This is one option. The second way is, I know the formula s is defined as average speed times time. That's v final plus initial speed divided by 2 multiplied by t. Now it will be better to use this formula because I know initial speed, I know the final speed, and t is also given. So I can easily calculate the total distance traveled by the car. So now s is initial speed is 0, that is 0, plus final speed is 6.6 meter per second, and divided by 2 and multiplied by 6.5 seconds. Now this, the total distance is 0 points plus 6.6 is 6.6 meter per second multiplied by 6.5 seconds divided by 2. Now let's simplify. I just will cancel out this second by this second. So the total distance is 2 by 2, this is 1 by 2, this is 3.3. So 3.3, you can use calculator in order to find the product of these two. 3.3 multiplied by 6.5. This will give us, this will be, this is equal to 21. The total distance traveled during this time is 21.45 meter. Here we have only meter. So this is the total distance traveled by this car during the 6.5 seconds. Now let's move on to the second example, to the next example. A car enters a freeway with a speed of 6.4 meters per second and accelerates uniformly for 3.2 kilometers. This is a distance in 3.5 means this t, this is s, and this is initial speed of the car. The car is entering to a freeway at this speed, so that's the initial speed. So we want to find how fast. We want to find the final velocity. This is v, but the answer has to be expressed in meter per second. So what are the given quantities? Let's list down the given quantities. The given quantities are Initial speed of the car is 6.4 meter per second. And the total distance traveled by the car is 3.2 kilometer, but don't forget to convert this to meter. So when you want to change kilometer to meter, if you want to change kilometer to meter, we multiply it by 1000. So when you multiply this by 1000, it will be 3200 meter. That's the distance. And T is 3.5 minutes. So don't forget to change this minute to seconds, and when we want to change minute to second, we will multiply it by 60. So 3.5 multiplied by 60 will give us, we want to change to second, then this is equal to 210 seconds. And what else we want to find? We are asked to find how fast means the final velocity of the object. So we want to find, these are the given quantities. We know initial speed, we know the distance traveled, and the time. We want to find how fast means, by the way, here don't forget that when it says how fast, we are asked to find the speed or the velocity. If it says how far, we are asked to find the distance. If it says how long, we are asked to find t. So don't forget these three words. Now let's solve it. Solution. Now which formula do we have to use in order to find the final velocity of this car, provided that initial speed and distance and time are given? So can I use the formula S? Now let's list down the formulas for final speed. We know that final speed is equal to initial speed plus acceleration multiplied by time. So if I want to use this formula, I have to find the value of acceleration first. What about if I use distance? I can also, by the way, I can use also the formula distance is equal to initial speed times t plus 1 over 2 at square. T is given, U is given, but we don't know A. So we have to find, in both cases, we have to find the value of acceleration first, then we can find the final velocity. Or I can use the formula distance is equal to the average speed, that's initial speed plus final speed, divided by 2 multiplied by t. Now this is the appropriate formula, I think, because we know the distance traveled, we know the initial speed, we know the time, so that we can find V easily. Now let's make V the subject of the formula. So I will multiply both sides by 2. Let's multiply both sides by 2. Multiply this by 2. Multiply this by 2. Then these 2 will cancel out by these 2. Then I will have here, 2 times S, 2S is equal to initial speed plus final speed multiplied by t. Now let's divide both sides by t. Divides by t and divides also by t. I want to make V the subject of the formula. Then I will cancel this t by t. Then I will have V plus U is equal to 2 multiplied by S divided by t. Now I want to find V, then I will take this to the right. So V, I want to make V the subject of the formula. Then V is now 2 multiplied by distance divided by t minus initial speed. Now I can find in this formula. Now it will be very simple to find the final velocity. Now the final velocity is given by, it's equal to, so V is equal to 2 multiplied by the distance traveled, which is 3,200 meters, divided by t. T is 210 seconds minus initial speed, which is equal to 6.4 meter per second. So this is equal to, multiply to the numerators together, 2 multiplied by 3200 is equal to, and divide the answer by 210, which gives which is 30 point. This is equal to 30 point to the nearest 2 decimal place, that's 48 meter per second, minus 6.4 meter per second. This is equal to minus 6.4 is equal to 24.1. This is equal to 24.1, nearly 24.1 to the nearest 1 decimal place, that's 24.1 meter per second. This is the final velocity of the car when it enters to the highway after traveling a distance of 3.2 kilometers. So this is where you can find the final velocity. Or another student, or you may solve it, or you can solve it by using this formula, provided that you find the value of acceleration first. Find the value of acceleration and then substitute it here. So you get the same formula. You can check it. You get the same answer. Let's move on to the third example. A car with an initial speed of 6.5 meters per second, that's the initial speed. Let's list down the given quantities. Initial speed of the car is 6.5 meters per second. Accelerates at a uniform rate of 0.9. This is the value of acceleration. Acceleration is 0.92 meter per second square for t 3.6 seconds. Find the final velocity and displacement of the car during this time. Here we are asked to find, what is asked is to find the value of final velocity and the total distance traveled during this time. So what is the final velocity and what's the total distance traveled during this time? Now let's solve it. Solution. So we know that initial speed, acceleration and t are given, so we want to find v. So let's find v. We know that the final velocity is given by initial velocity plus acceleration multiplied by t. So initial speed is given, acceleration is given, t is given, so that we can find v easily. So v is now 6.5 meter per second plus acceleration is 0.9 meter per second square multiplied by, this is 0.9, t is 3.6 seconds. Now cancel the second by this second square, then we will have final velocity will be 6.5 meter per second plus multiply 0.9 by 3.6. You can use calculator. 3.6 multiplied by 0.9, which is equal to 3.24. This is 3.24 meter per second. Now final velocity is equal to, you add with 6.5, the answer will, then you will get 9.74. The final velocity is 9.74 meter per second. So the car will have a speed of 9.74 meter per second after traveling for 3.6 seconds. Now let's find the total displacement traveled by the car, B. Let's say I'll call it B. Now displacement can be calculated by, now distance, I can use the formula. The total distance traveled is, I can use the formula ut plus 1 over 2 at square. I can use the formula because I know the initial speed t and a. So everything is given so that I can use this formula. So s is now, initial speed is 6.5 meter per second multiplied by t is 3.6 second plus 1 over 2. Now let's forget the years. Multiply by 0.92 multiplied by t square. That's 3.6 second square. Now I'll continue here. So the total distance is equal to multiply 6.5 multiplied by 3.6 is equal to 23.4. Now you can cancel the second by second. Finally you will have meter plus 0. Here you just 3.6 times 3.6 square root 3.6 multiplied by 3.6, which is equal to, and multiply the answer by 0.92 multiplied by 0.92 is equal to, and divide the answer by 2. This will give us 5. This is equal to 5.996. Let's say 96. So here I will have second square, and here I will have, look, meter per second square is the value of acceleration multiplied by second square, which is t, so that this second square will cancel by second square. Finally I will have meter. So the total distance traveled is equal to plus 23.4 is equal to 29. This is equal to 29.36 meter. This is the total distance traveled by the car during this time. Now let's move on to fourth example. Example number 4. A driver of a car traveling at 15.8 per second applies the brake, causing a uniform deceleration, slowing down. So how long does it take the car to accelerate to final speed of this final speed? So here the car was, let's list down the given quantities. The car was initially traveling at a speed of, that's 15 meters per second. Now the car is decelerating. It's decelerating at the rate of 2 meters per second square. The negative sign tells us the car is slowing down, or it is decelerating, and it reaches a final velocity of, the velocity reaches 10 meters per second. So how far the car moved during this time? We want to find, what's asked is, required is how far. We want to find the distance traveled by the car during this time. When you say how far, we are asked to find the total distance traveled by the car during this time. Now let's solve it. Now I know the initial speed, the final speed, the value of acceleration, so that which formula do I have to use, provided that these are given. Let's use the formula, final speed square is equal to initial speed square plus 2 multiplied by this formula. I can read this formula now. So the final speed square is 15 square. 15 square, let's forget the is equal to, sorry, the final speed is 10. I'm sorry, it's not 15, it's 10. Final speed is 10. 10 square is equal to 15 square plus 2 multiplied by acceleration is negative 2 multiplied by distance. So 10 square is 100. This is 100 is equal to 15 square is 15 times 15, which is 225. You can multiply 15 by 15 using calculator, then you will get 225 positive, and then 2 times negative is negative 4s. Now let's collect number to number now. Let's bring this side. Let's bring this to the left. That it will be 100 minus 225 is equal to negative 4 times s. So when you subtract 100 from 225, it will be negative 125, which is equal to minus 4s. So to find s, we divide both sides by negative 4. Divide by negative 4 and divide also by negative 4. Now, this negative will cancel out by negative. Negative 4 will cancel by negative 4. Then what's remaining is total distance traveled is given by 125 divided by 4, which is equal to 31.25 meters. This is the total distance traveled during this time. So the total distance traveled by the car is 32.25 meters.